Welcome to Notes 5.5, Solving Equations Involving Absolute Value. This is for Algebra 1. The goal of this video is to become more aware of and familiar with absolute value and how it relates to solving equations. Expressions with absolute values define an upper and a lower range in which a value must lie. Expressions involving absolute value can be evaluated using the given value for the variable. The key word here is value, which is found in evaluated. It means find the value after substitution. For example, if a survey on the reading habits of people in the U.S. resulted in 46% of people reading popular fiction with an error of plus or minus 3%, what percent of people could read popular fiction? So what this is really asking us is to find the range of people, and if we subtract 3% as well as add 3% to 46, that will give us a range of 43 to 49%. So let's look at number 1 here and try to remember the idea that if absolute value, we're going to come up with two different numbers, just like the 46%. We're going to, a lot of the time, come up with a number on each side. So in number 1 it says m plus 6, absolute value of m plus 6. Well, think of the absolute value symbol as a grouping symbol. So we're going to have 4 plus 6. And then it's minus 14. So the grouping symbol, just like parentheses, let's take care of what's inside of the parentheses first. Absolute value of 10, and then we have minus 14. Absolute value of a number is really the distance that that number is from 0. So the distance that 10 is from 0 is 10. So we have 10 minus 14, and 10 minus 14 is negative 4. And so the solution to number 1 is negative 4. Okay, moving on to number 2. It says evaluate 23 minus the absolute value of 3 minus 4x if x is 2. And in this case, we have 23 minus the absolute value of 3 minus 4 times 2. So just like parentheses, let's treat these as grouping symbols. Let's go with order of operations. 23 minus the absolute value of, multiply before subtract, 3 minus 8. And so what we now have is 23 minus the absolute value of negative 5. Okay, so we know that from the previous question, absolute value is the distance that that number is from 0. And so we have 23 minus the absolute value of negative 5 is 5. Distance is always positive. Okay, 23 minus 5 is going to give us 18. And in this case, when x is 2, our answer is 18. All right, number 3 I like because it really does a good job of representing the idea of absolute value and how you can actually have two numbers be the same distance from 0. It says the margin of error in the example at the top of the page is an example of absolute value. Graphically represent the percentage of people that read popular fiction. I'm just going to focus on the plus or minus 3 instead of the 46%. If I am on a number line and I'm looking at 0, right here, I could have 3%. I could also have a minus 3%. Okay, and so you could have anything in between here, including the negative 3 or the positive 3, still be included. So if you want to think of it in terms of graphing that, go ahead. There's what you would be looking at as a graph. But I really want to focus on the idea that negative 3 is the same distance from 0 as 3. Okay, let's look at number 4. It says solve for x. The absolute value of x is equal to 4. What that means is the value of x could be either 4 or negative 4 because the value of x is 4 units from 0. So we have two cases. We have a case where x could be 4. We also have a case where x could be negative 4. Okay, so again, this relates to number 3 in that you're going to have the same distance on both sides of 0, 3 units to negative 3, 3 units to positive 3. All right, so in this case, kind of translate that to number 4 where it says we're going to have two cases, a positive case and a negative case. What this will do is translate into number 5 where it says solve each equation and then graph the solution set. We'll solve this first. We're going to have two cases. The value of f plus 5 is going to be 17, but it could also be negative 17. And so what we have here is f plus 5 equals a positive 17. Okay, the value of absolute value of f plus I is 17, and we could also have it as negative 17. So what we have then, if we solve this as any equation, subtract the 5 in order to isolate the f, and that would give us f is equal to 12. But we also have over here, subtract 5, and we'll get a different solution. F will be equal to negative 17 minus 5 is negative 22. Okay, so number line would be required to graph the solution set. What I did was start with negative 6. I scale by 4s and need to make sure that it scales appropriately to fit 12 as well as negative 22 on the number line. And if we want to graph the point or the number 22, negative 22, put a dot at negative 22 as well as a dot at 12. That should be halfway between 10 and 14. What I would like you to do right now is try number 6 on your own. Press pause on the video, and when you have a solution, pause the video and check your answer with mine. Okay, let's check your answer to number 6. Make sure that you have both the negative and the positive case, and that would give you equals negative 3 as well as equals positive 3. When you go through and solve, you get b equals negative 4. You also get b equals 2. And on a number line, if you're going to graph that solution set, you should see a point at negative 4 as well as 2. For now, let's skip number 7. We'll go over number 7 in class together, so make sure that you circle that, and don't let me forget to go over it with you. We're going to move on down to number 8, where it says to solve the absolute value of 2x minus 3 minus 4 equals 3. What I would like to do before we come up with our two cases is add the 4 to both sides, and what that does is gives us an equation that is similar to what we've already done. So that would give us the absolute value of 2x minus 3 equals 7. Okay, now we have our two cases, right? We have our positive case, we have our negative case. I know we didn't write this out earlier, but it's kind of what we were doing. So we have our 2x minus 3 equals positive 7. We also have 2x minus 3 equals negative 7. Okay, go through and solve. Use the inverse operations. You're going to have 2x equals 10. Okay, and undo the multiplication with division. So x is equal to 5. On the other side, or the negative case, let's add the 3 to both sides. What we get is 2x equals negative 4. Now you can see where the difference is coming in, where you're going to get a second solution, and you're going to get x equals negative 2. At this point, let's skip number 9 as well. I will go over number 9 in class with you tomorrow or next class. So I hope you understood the video. Again, circle any questions that you need clarification on, and I will see you next time.